Hello students, welcome to Python programming class, lecture 12. Today we are starting unit 2 part 3, fruitful functions. The content of fruitful functions: return values, incremental development, nested functions, boolean functions, more recursion, checking types. So these are the topics. We will discuss first three concepts in this lecture 12 and the remaining three concepts in lecture 13, next lecture, right? Okay, let's get into the lecture 12. First topic, return values. What is meant by return value? First, we need to know about functions. In the function, set of statements are there, some sequence of statements. We can use return statement in the function, right? In the functions only we are using return statement. We are not using return in anywhere else. Okay. As soon as the return statement executes, the function terminates without executing the subsequent statement, right? First, consider function without return statement. So how it will work? Consider one function, some statements in the function. Consider one main program, statement 1 executed, statement 2 executed, and then call the function. When we calling the function, the total statements in the function are executed, and then next statement is executed in the program, and then here we are calling the same function once again. Total statements are executed and continues. Like that, the function works without return statement. Now, coming to the functions with return statement. Consider same function, statement 3, 4. I am placing return statement, statement 5, 6, so on. Same program, statement 1 executed, statement 2 executed, calling the function. And you calling the function, up to return statements are executed. So statement 3, statement 4, return or executed, and then return to the main program. And statement 7 executed, and once again you are calling the same function. Once again statement 3, statement 4, and then return executed, so on. Here statement 5, statement 6, so on. These statements are not executed. That means the statements after return statement are not executed. Here statement 5, statement 6 are not executed, called dead code. This is function with return statement. Let's check the examples in the Jupyter lab. Now coming to examples of return statement. First, create one function, define greet. Greet is a function name. Give one parameter or argument name. How to terminate the header part? By using colon. Enter. Now give the body of the function print. So what you have to print? Hello, name, good morning. Run the code. So after creating the function, you need to call the function for execution. So how to call the function? Greet parameter name. So I'm giving Ram. Run it. Hello Ram, good morning. Right? Now assign the result to a variable for checking the type. A equal to greet of Sam. Run it. Hello Sam, good morning. Now what is the A value? Hello Sam, good morning. Now check the type of A. See here, A is non-type, but hello Sam, good morning is string. Why? The type of A showing the non-type means in the function there is no return value. Just you are displaying the result by using print statement. Slightly I am modifying the code. Take this. In place of print, I am using return. Return. Hello. Same. Hello. Name. Good morning. Run the code. Hello Ram. Good morning. So A equal to greet of Sam. Right? Now check type of A. String. Right? Then you will print of A. So what is print of A? Hello Sam, good morning. So that is string type. So when you use the return statement, the value is returned, the corresponding value. So it is string or integer like that. Right? Now same example, one small statement. Give print indentation, print of same, and then print of name. Not like this. Right? Delete all this. No need. Now run the code. Call the function greet of Ram. Run the code. So what is the first statement here? Print of hello plus name plus good morning. So hello Ram, good morning. What is the second statement? Print of name. So what is the name here? Ram. That is also printed. So when you calling the function, how many statements in the function all are executed? The all statements in the function are executed. So in this function, two statements are there. These two are executed. So hello Ram, good morning and Ram. Now replace print with return. Run the code. You will get only hello Ram, good morning. Here you are using return. So return to the main program, right? So the statements after the return statements are not executed. So what is that code? Dead code, right? So the statements after the return not executed, right? So these are the return value statements. That's the return values topic, first topic. Now coming to the second one, incremental development. What is meant by incremental development? Some functions are very larger in size. They are very difficult to debug. So we need to deal with complex programs or complex functions by using incremental development. So what is the main goal of the incremental development is we are avoiding debugging for long programs and we are testing only the small amounts of code at a time, right? Let's check one example for this. Suppose you want to find the distance between 2 points x1 y1 and x2 y2, right? You want to find the distance by using Pythagoras theorem. The formula for distance is distance equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So calculate distance by using x1 comma y1 and x2 comma y2 in the Jupyter lab. Now coming to the example for incremental development. Here also create one function. Define the function name is distance. Coming to our example, we need 4 arguments. So x1 comma x2 comma y1 comma y2. So 4 arguments, right? Return 0. So no code, run. Right? When you call distance of 5, 6, 7, 8, you will get 0 because it returned 0. Now, incremental development means step by step you have to find the result. So, what is the formula? You need to calculate square root of x2 minus x1 whole square plus y2 minus y1 whole square. Now, calculate x2 minus x1. Dx equal to x2 minus x1. Dy equal to y2 minus y1. Run the code. No errors. No errors. Return 0. Right? If you get 0 here, the code is correct because it's returning 0. There is no errors. Now, x2 minus x1, y2 minus y1 is completed. Now, you have to calculate x2 minus x1 whole square. Similarly, y2 minus y1 whole square. So, dx1 equal to dx whole square. That means star star 2. Dx star star 2 means dx square. What is dx here? x2 minus x1. So, dx star star 2. What is dy1? dy star star 2. Right? dy star star 2 means dy square. So, x2 minus x1 whole square, y2 minus y1 whole square completed. In the code, yes, we got 0, return 0. Now, add equal to addition equal to. So, what do you have to add here? dx1 plus dx2. Run the code. Yes. Yes, you got error here. So what is the error? dx2 is not defined. So step by step you are identifying the errors. So here dx2 not there. So dy1 is there. dx1 plus dy1. Run the code. Yes, you got 0. Now x2 minus x1 whole square plus y2 minus y1 whole square completed. Now you have to find the square root of this one. So you need to find the square root sqrt of. So the function is sqrt for square root. So what is the argument for sqrt? Add. So add. Run the code. Yes, you got error. What is the error here? SQRT is not defined. SQRT is not defined means where is the SQRT function? In the math module. Okay, check the previous lectures. In the math module. So you have to give math dot sqrt module name dot function name. Run the code. Once again you got the error. name math is not defined. So name math is not defined means what you have to do, you need to import the math module before function. So import math, import math. Now run the code, got 0, right? But that is not 0. So assign the final result to result variable. Now result equal to math dot sqrt of add. What you have to return? You need to return result variable. Run the code, run. So this is the result 1.414, right? So check the result. 6 minus 5, 1. 8 minus 7, 1. Right? 1 square, 1. 1 square, 1. 1 plus 1, 2. Square root of 2 is 1.414. Right? So that is the example for incremental development. So that's the incremental development, second topic. Now coming to the nested functions. So what is meant by nested functions? One function from within another. We are calling one function from within another function is called nested functions. This ability is called composition, right? Let's check one example. Here, find the area of circle underscore area. This is the function name. Here, 4 arguments are there, xc, yc, xp, comma, yp, right? First, find the radius of the circle. So radius is the distance of xc comma yc comma xp comma yp. So you are finding the radius by using the distance function. By using the distance function. So this is the distance function. Now you are finding the result by calculating the area with the radius value. So here result is a variable, area is another function, radius is the argument which is already calculated in previous statement, right? So after calculating the area, the result is returned. You can compose the same program into in different method like this. So here same thing, you are calculating the area of circle underscore area xc yc xp comma yp. Here directly you are using return statement. So you are returning the area, so return area. So what is area here? Radius. So what is radius here? Distance of xc comma yc comma xp comma yp. So area of radius, in place of radius write this distance of xc comma yc comma xp comma yp, right? So these are the nested composition of the functions. So what is mean by that? You are calling one function within another function, right? So that's the third topic, nested functions. That's the today's lecture, return values, incremental development and nested functions, right? We will meet in the next lecture. Thank you.